Hello, I'm Martin Fouillol. We are back on day 3 of the HMN Network Wheel Reinvention Jam, for which I'm programming a live coding audio environment. Yesterday, I didn't have time to start working on the hot reloading code feature, so that's what we are doing now. There are a number of UX questions that will have to be answered at some point. Such as, do we want to let the user use their preferred editor and their preferred build system? Do we want to let them manage their project's directory structure? Or do we want a more integrated experience? I think there's advantages to both options. It has some value to be flexible and let the user use their preferred tools. On the other hand, if you want to just start a project very quickly and just start typing some DSP code, it would be great to have some predefined project structure and some predefined build scripts, and to be able to build the DSP from within the application, for example. But for now, we will do the most simple thing, which is just reload a library at a hard-coded location, and then we'll start from here. So let's do it. Okay, so now we have the basic steps to reload the user-provided library. So I have this user function, user info structure here that contains the pointer to the user module and a pointer to the user DSP function and a timestamp of the last modification time. So I've put that structure in my application structure. And then I have a function to reload a user module here. So I pass it in user info structure and the name of the library to reload and the last modification time of that library file. So here I'm just closing the library if it already is loaded. And then I try to DL open the library and to find the DSP symbol, and I update the last write time. Then I'm starting the file. Here it's a predefined location, and if the last modification time of the file is sooner than the already loaded library modification time, I reload the library. So inside my OSX render callback, here I'm checking, and if I have a DSP function, I call it. Otherwise, I'm just filling the output buffers with zeros to silence the output. So now I have separated my DSP function in another file, testuser.dsp.c. It's the same DSP process than before, and I have also set up a flag to my build script to build this user DSP file into a shared library. So I can start the application now. We see that it's loading. We see in the message here that it has loaded my DSP function, and I could, for example, change the frequency of the sine wave here and rebuild only the DSP file, and can see it changed. That's the very basic steps to implement the hot reloading feature. So now we have to answer some design questions. So you see that for now the library is at a hard-coded location, so we have to communicate to the program where to find that library. And it would be great to have a keystroke to rebuild the DSP library from inside the application. So I don't want to spend too much time trying to come up with a very good idea or a very good story about project UX. So I will go for the simple thing, which is that I will set these paths in a text file that will be the project settings file, and then the application will load the project setting and it will find the build command and the path to the library in here. So let's do this. Alright, so I implemented the project settings file. So I created that directory for my test project here, and the settings for the project are all in this DSP project file, which is simple text files with keys and value pairs, and we have two pairs here. Lib is for the path to the dynamic library, and build is a build command to build the DSP from the application. The rest of the project directory structure is up to the user. The build command can be anything, and the sources can be organized as they see fit. So I think it's really simple, and we can also in the future dump other settings into that project file. For instance, we can maybe record the audio parameters and the preferred input and output devices, that sort of things. So it's quite simple, but it will be enough for now. On the front of the application, I have this project setting structure which just contains strings for the working directory, the library path, which is relative to the working directory, and a build command. Then I have coded a very dumb and stupid parser. I'm like 100% sure that it's full of stupid bugs and it's not robust, but it was just a quick thing I wrote to get something up and running. And next we have our build command, which is bound to a hotkey here. So if I press Command R and my build command is defined in the project settings, I execute that command. So I can maybe just show. And now I have my DSP file here. I can change settings. I change the frequency, and I can directly compile and reload from the application. So now we are going to tackle something a little bit different. You may have heard that reloading the DLL stopped the audio because as we are doing now, the reloading is called from the event callback. Here in my frame event, I check if the DLL needs to be reloaded, and it will be reloaded in this thread, which is different from the audio thread. So there is a synchronization problem. I think we would also need to stop the audio if we did the reload as we do here, but in the audio thread, because the time it takes to reload the library may be longer than the time it takes to render a buffer. So what I think I will try now is to load the next version of the DLL side by side with the old version in the main thread, and then in the audio thread we will just have to swap pointers. Basically, just before rendering a buffer, we will check if we have a new version, and we will swap function pointers here, so the time taken by the DLL reloading won't stop the audio. So we will try to do that now. So now we finally have the code reloading happening in the main thread and loading the new library side by side with the old one, and we are just swapping pointers in the audio render callback, and then we unload the old version of the library. So let's do a quick demo. I can open and hear my sine wave, which is currently set at 440 Hertz frequency, and let's say I want to change it, and then I can rebuild the DSP in the application, and it switches without shutting down the audio, so working as intended. Alright, let's do a quick recap of what we did today. So we started with the very basic functions to implement the code reloading feature. It consists in a function to load a user DLL and import a DSP function, and a function to monitor the DLL modification time and to reload the library when it has changed. I then devised a very simple file format to store the project settings. It points the application to the user's DLL, and it also stores a build command. So it lets the user organize their project structure as they want, and it also allows rebuilding the DSP code from inside the application while still letting the user choose their preferred build system. Next, I split the reloading code between the audio thread and the main thread, so that when the user's library changes, the main thread loads the library while keeping the old version along. And when all the preparation work is done, we can just swap pointers inside the audio thread and signal the main thread that it can unload the old version of the library. So it allows us reloading DSP code without shutting down the whole audio system, which makes for a more pleasant live code editing experience. So that was today. Tomorrow I think we will probably start by working on data persistence, because the DSP function will probably use some data when it gets more complex, and we want that data to persist across reloads. Until then, have fun jamming. It's super interesting to see all the cool ideas people come up with, and I think now I'll take a look at other projects' progresses. So see you tomorrow.